Welcome to the introduction of Python. Let's get started. This is what we're going to cover today. Our core topic will be Python. And as part of that, we're also going to cover the command line use. And basically, you can run Python programs in two ways, either as a program or in Python's interactive mode. We will be mostly dealing with Python running as a program. So let's get started. First of all, here you see our overview of how the computer abstracts away the programs that we write. At the lowest level, we have machine language, also known as object code. Any code at that level consists entirely of zeros and ones. Now, this would be very burdensome for us as humans to program. And so we are going to use assembly language. An assembly language is, for example, x86, which is for the Intel CPU family. And one example that we used is the NASM programming language, net wide assembly. Now, there is a one-to-one correspondence between each assembly language instruction and each machine language instruction. There is a literal translation of every instruction that we write in assembly to its machine language equivalent. Now, this is very close to the hardware. So assembly language is hardware specific. We're writing it for one specific CPU, and as such, we're also concerned with the low-level details. For example, assigning particular values to be stored in memory, moving them to register, moving them back to memory, and so on and so forth. So this is a very detailed view of a program. And as computer scientists, we're generally more interested in the algorithms that we write. And that is what our high-level programming language focuses on. So if you write your program in C, C++, Java, or Python, as we will do, we will abstract away the underlying details of the hardware. That is not of concern to us. What is of concern to us is how do we structure our algorithms, how do we run them, and how do we store the data in an abstract sense, but not in the way of thinking about the underlying electrical engineering part. That is something that electrical engineering and computer architecture is about. And so we go from the high-level programming language to assembly language by a program that translates the former to the latter. That's a compiler. And we can go from assembly language to machine language via an assembler. Specifically, what we're going to do is we're going to write our programs in Python, and then we use the Python interpreter. The Python interpreter translates in real time the code that you write into a lower level. And in particular, for Python, that is called bytecode. So you can think of the assembly language version of Python as bytecode. Now, that's not precisely what would fall under the narrow definition of an assembly language, but you can think of it that way. And then this bytecode will be run on the Python virtual machine. And the Python virtual machine enables us to abstract aware the bare metal or the computer, the CPU on which we are actually running our code. So we are not concerned with the underlying machine. We rely on the Python virtual machine to execute that for us. There are different backends that make sure that whatever we write in Python is correctly executed using the Python virtual machine for the particular architecture on which we want to run our programs. And so from this point on, We are more talking about the algorithmic and data structure side of programming and computer science, and we are less concerned with the underlying architecture. Now, before we can get started, we first need to get Python to our computer. In principle, that shouldn't be too difficult, although, as you can see here on the left side, there are many different ways how you can install Python on your computer. If you don't want to immediately jump into Python, installing it on your computer, you can also try it out online. For example, there is the Replit website where you can just enter Python syntax into an interactive window and you can run it there to see how it works. But ultimately, you need to have Python on your computer. And we will cover later in the lecture how you're going to do that. Now, there's one important note as to the Python versions. There are two main versions, which are Python 2 and Python 3. At this point, it's pretty clear that we should be using Python 3. Python 2 was retired in 2020, but if you have a Mac computer, your Mac OS still ships with Python 2. So you need to install Python 3 on your computer. There is a breaking change between these different Python versions, and programs that you write for one may not necessarily run for the other, depending on which elements of the language you're using. And we are going to work with Python 3 going forward. If you have a Windows computer, there is no Python version included by default, and so you would need to install Python 3 from scratch. The easiest way to install Python on Mac OS is going to the official Python website, go to the Mac OS section, and then download the latest stable release using the installer. You can also not use an installer, but it's less convenient. So pick the latest version using the installer. If you're on a Windows computer, you can do the same. Pick the 64-bit Windows installer, download it on your computer, and follow the prompts that you would usually do when installing any other program. This will then install the Python virtual machine as well as the Python interpreter on your computer. So you can think of it as any other program that translates your Python code into executable machine language code that can be run on your computer. If you're using Windows, there's one very important point during the install process that you should keep in mind. If at any time during the install process Windows asks you whether Python should be added to the path variable, please click yes. This will connect the Python installation that you have to the system, so that your system knows, okay, if you enter a Python code or Python command, rather, that it knows where is Python actually installed to run this program. If you don't do that, your system will not know where Python is installed, and it will throw an error. If you don't add Python to the path variable, then the easiest way is to uninstall Python and reinstall it again. So there is an uninstaller that comes with your Windows Python installer. You can click on that and then uninstall the program, the Python program, by just going through the uninstall instructions. Okay, now we are mostly going to work with Python programs. There are two ways, as I mentioned, to run Python. One is through the command line via the Python interpreter directly, and the other is to run actually the programs that you write in files, .py files. And in order to create these files, it's good to have a code editor. And so I'm going to use Visual Studio Code, but you can use any editor that you like. There's also Atom, Vim, or Emacs. That does not matter. What matters though is that you don't use an editor for text editing, because text editors will add additional formatting that may not work properly when we have program code. And so we want to avoid text editors. So pick any code editor that you like. You can also use what is called an integrated development environment. And for Python, there is PyCharm available. If you go to the website given here, you can also get the professional edition for students. If you upload your student ID, you will get it for 1 year, and then you have to renew the PyCharm edition every year as long as you're a student. If you're no longer a student, then you have to pay for it. Now, what is an IDE? An IDE is essentially a fancy text editor. It tries to help you in your programming, for example, by pointing out syntax errors. But these days, actually, the line between IDEs, integrated development environments, and text editors such as Visual Studio Code is blurry, because many of the features that were formerly only included in IDEs are also part of text editors these days. I will mostly use Visual Studio Code going forward. If you want, you can also use the built-in IDE in Python. So if you use the installer, it comes with idle. You can click on the idle icon to run it, but that is not as good as an IDE as PyCharm. Okay, what we need first is to understand how does the command line, also known as terminal or shell, work. And there are two distinctions, or rather there are two different types of command lines. One is the Unix shell, which is distributed on Linux and Mac OS and other Unix-like operating system. And then we have the DOS shell, which is on Windows computers. Now, if you have a Unix system, then you don't need to do anything. Your system comes with a default shell. If you are on Windows, however, you would need to install a Unix shell or a emulator to run the commands that we're going to explore. Now, this is the shell. This is how it looks like. And I can switch to my installation here of the shell. So I am here on Mac OS. I'm going to open my shell, and the one that I'm using is actually the fish shell. The first command that you can see, I can actually clear my screen here, and I will make this a little bit bigger so it's better to see. Okay, so basically the way you can think about your terminal or your shell or your command line, I'm using them these expressions synonymously, is you are able to execute code, start programs, anything that you can do through the graphical user interface through this text interface. And if you imagine, initially, computing was purely based on text. And then, Bill Gates came around with Windows, and, Steve Jobs and Steve Wozniak of Apple to actually introduce the graphical user interface. But before that, we actually operated on computers via text only. And so in many programming tasks, this is still done today because it's usually quicker than going through a user interface. The user interface is also another layer of abstraction that we often don't need, or that is getting in the way of our tasks, actually. That is, why many people use the command line. Whether you're on Windows or on Mac OS or Linux, this will look very familiar or very similar to you when you do this. I can switch to a different shell. As I mentioned, I have the fish shell, but for example, the built-in shell, I can access it by typing its name here, ZSH, and I will be in the default shell. But I can also switch to the fish shell. I prefer that, so I'm going to run that. If you want to get it in the slides, here is the URL where you can download it. And also I give instructions how you can use it as your default shell. Now, if you are on a Windows computer, what you can do is you can get Commander, which is the command line emulator. So you can go to this website here, download and install Commander, and then everything will be working for you as in a Unix-like operating system. Another thing that you can do if you're on Windows is install Linux on Windows with the Windows subsystem for Linux. And so here's the URL given for how to do that. I have not tried it myself, so I'm not sure how complicated it is or how well it works. Probably the easiest solution is to use the Windows command line, but if you're curious, you can also try this. Now, let's talk a little bit about working with the terminal. Let's talk about some basic commands. We already have seen the clear command. If you wanted to clear your terminal of previous commands that you have used, you can use that. And here are some more. pwd gets the present working directory. ls lists the current directory contents. cd allows you to change into a directory. cd goes up a directory level. Python 3 on Mac or Linux starts the Python 3 interactive mode. On Windows, you would just type Python, even though if you run Python 3, the command on Windows is just Python. And if you want to run a program, you would run Python 3 and then the program name. So let's go and explore that a little bit more. So let's try out these different commands. As you can see here, I am logged in as the user as Zimmeck. This is my computer name, Starship. So depending on what your username is and how your computer is called, you would see a different string here. And then you see where I am located in my directory structure at the moment. If I wanted to see that more extensively, I can type pwd, which means present working directory, and then I see the full path on which I am located. So I am on my Mac OS computer in the users folder as Zimmeck desktop and code. Now I can list all the items that are in my code folder by typing ls. And so here you can see, for example, the materials for 114, how to talk to machines. So these are my lecture slides and the other materials related to the class. If I wanted to go deeper into these directories, I can use the change directory command. So I would type cd and then, for example, 114 httdm. And as you can see, my fish command line interface, my terminal here is auto-completing because it already recognizes, okay, that's where I want to go. And if I run this command, then I am actually now in the 114 httdm folder. I can confirm that by typing pwd again, and you can see indeed we have moved to this folder. So this is really exactly the same as if you were on your graphical user interface. For example, here is my code folder, and if I would do a double click on this, I would get into the folder here as well. It is exactly the same command, just without the additional abstraction layer of the graphical user interface. I can again list the different files that are in this directory, and as you can see, it lists here individual documents as white and then blue here as the folders. Now, if I wanted to go back up again into the code folder, I can do cd ... This will bring me back up again to the code folder. And so this is the way how you can navigate back and forth and deeper and higher in your directory structure using the command line. Okay, now if you have installed Python, as we discussed previously, you can check if your Python installation is running properly. So let me clear this a little bit. And now what you can do is, if you are on macOS, you can run Python 3, or if you're on Windows, you would just run Python. And if you do that, then it will tell you, if you have Python installed, which version of Python you have installed on your computer. In my case, that's version 3.10.8, and so that's the current version of October 13, 2022. That's probably also the version that you get at this point. And then, as you can see here, now we have these 3 arrows. And so that means we are actually in the Python program at this point. So we can type Python program syntax. We are no longer in the terminal. We are in the Python program. And so what we can do, for example, is we can type a print statement in Python, print hello, for example, and this will print hello to the screen. Print hello, as you can see. Python also allows you to do arithmetic operations. So, for example, I can do 3 + 4, and it will return the result. So this is what is called the Python interactive shell, or Python interactive program. We are not going to work a whole lot with that because we are actually writing our Python code. So, for example, the print statement that I did here, or the 3 + 4 that I did here, not in an interactive shell, but rather we're going to write that in Python program files, and then we're going to run the code from there. You can exit the Python interactive shell here with exit, and now you can see these 3 arrows are gone, and I'm back in my usual terminal. And for example, if I would try to run the print statement here, right, it will not work because I am no longer in Python, right? So I get an error message. Fish is telling me illegal command name, print hello, right? This is not recognized anymore. I am no longer in Python. So while this may look very similar, if you want to run Python interactively, you first have to get into Python by, in this case, for Mac OS, typing Python 3. It will not work in the terminal as such. Okay. Now let's talk a little bit about how to actually run a Python program. So as I mentioned, there are in principle 2 ways to run Python. We already just discussed the Python shell. So you open your terminal, type Python 3 for Mac OS or Linux. For Windows, you would just type Python to execute Python instructions. But then the second way of running Python is through a program, through a Python program. The way to do this is that you are going to create a .py file, store it, and then you run from your terminal Python 3 and the name of your file .py. And so that is also what you're going to do in all of your homeworks. So let's get started with that. As I mentioned, I am using Visual Studio Code. So I've installed Visual Studio Code on my computer. And so the first thing that I'm going to do is I'm going to create a Python file. So I'm using Command S to bring up the dialog for saving a file, for storing a file here. And let's just call it my program. So you can pick whatever name you like. And then you're going to select the .py file extension to identify to your system that you're going to write a Python program. Before, we have worked with text files, right? So you have submitted your program as .txt, and now you're going to submit them as Python files. They're also called scripts. In any language that you use, that will be true. For example, if you have JavaScript files or scripts, you would be using the .js extension. If this is, CSS, you would use CSS, and so on and so forth, right? But so in our case, we're going to use Python. And so I'm going to create a myprogram.py file. Okay, now my Visual Studio Code instance here is now aware, okay, this is a Python file. It's, selecting here Python. And if this happens to you, that's okay. You can just, get rid of this by the way I just did it. You can see here also something else interesting. So first of all, this is the encoding that we're using. UTF is the Unicode encoding. And so everything that we will write here will be understood as Unicode. This can also be changed. And so let's get started writing our Python code. As we have seen, for example, we have the print statement. And here you see that our Visual Studio Code already tells us what's the usage of this syntax. And so here it tells us, okay, we have the call to print, to the Python print function, and then we include here the arguments that we would like to print. So we can do exactly the same thing that we did before. We can just say print hello. And so this hello is a string. So this is not an integer, some kind of number. This is a character string. That's, how you use it. If you use these quotation marks, it will be recognized by Python as a character string. I'm just going to save this. And now, for example, if we go into our terminal and I would say ls, we will see actually here I have stored my underscore program.py, and now we can run this program. So I'm going to clear this, and I'm going to say, okay, Python 3, and then we are going to run my program.py, just like so, and it runs as expected. It prints hello. So this is the basic way of how you would run Python programs. You can write any Python code that you would like. So just, as we did before, we can write, 3 + 4. So let's see what happens. I've saved this. Now I'm going to run my program again. And by the way, as you have seen, I did not type this, right? I did not type Python 3 my program.py, but rather I can use the up arrow and down arrow buttons in my terminal to get to the program commands, to the terminal commands that I have used previously. So you don't actually need to retype all the time Python 3 my program.py, but rather you can use the up arrow on your keyboard to bring up the previous commands that you have used. And so I'm going to run this again. It still prints hello, but then evidently nothing else. And what could be an explanation for that? Well, this 3 + 4 is legal Python syntax. So Python has calculated this, but we are not going to print this result, right? And so if we wanted to print that, we would need to use also a print statement, similar like here. But we have not done this. And so that's why only hello is being printed here. But for example, we could do the same thing. We could say print 3 + 4. And then I'm going to save it, Command S on macOS, run it again. And indeed, now the result of our calculation 3 + 4 is being shown, being printed on the screen here. So this is the basic way of how you run a Python program. And you can imagine you can write, many more intricate, lines of code here. This is just an example of what you can do. The important point is that you first get your setup, and then, over time we will develop more sophisticated programs to run on our systems. Okay, now the 2 ways to run Python code. First of all, the Python shell, and then a Python program in a .py file. And the second method is what we are going to use going forward. Here is the summary again. Write Python code in a text file, save the file with the .py file extension, run the file by navigating in your command line to the directory where you saved the file. You can use the cd or change directory command, and then execute your program with the command python3, name of your file.py. You have to be outside of Python's interactive shell, otherwise it will not work. Now, here are some of the operations that we're going to cover in the next couple of weeks. We are going to talk about arithmetic operations. So a very simple arithmetic operation we have just seen, 3 + 4 returns 7. And so we're going to talk more about this. We're also going to talk more about strings. We have seen the string hello, and there are certain string operations that we can use. For example, we can concatenate different strings. If we go back to our file, we can, for example, say, all right, we have the string hello, and we want to say maybe more than just hello. We can say hello world. And what this plus does is that it will concatenate the string hello and the string world and print it as 1. So let's see how that looks. And indeed, it is what we expected. This operand plus concatenated these 2 strings. That also shows you one other important aspect of Python. Operators are overloaded, meaning they can have different meaning depending on the context of use. If we use the plus in connection with 2 strings, it means concatenation. If we use the plus in connection with integers or other numbers, it means addition. And so you have to be mindful of the context in which you are using this plus operator. Also, what's important, new blank spaces here like this won't matter for Python. So I could equally write my code like this, and there would not be any difference. Now, what will make a difference is indentation, and we will get to that later on. For example, if you write a statement like this, you indent it, that will have meaning in Python, but it will not have meaning if you have, white space like this. So you can structure this the way you like. I think, it's easier readable if you have a little bit more white space here. So I'm going to do it like this. Okay, so we're going to talk about strings and string operations. We are also going to talk about built-in and additional libraries. So what are libraries? Libraries is written code by other people. So these can be official libraries that are part of the Python system, or these can be additional libraries that are not part of it. The idea here is that we have many functions that many people want to run, and so not everybody has to write them. Rather, just one person has to write them, and then we can actually share them. If you think of it, for example, arithmetic operations are very common, and so it would not be very effective if everyone would write their own version, their own implementation of arithmetic operations. We will cover variables and assignments. So for example, in Python, you can create any variable you like. So here, for example, is a new variable, and you can assign it a value. For example, the value 5. And so what this means is that in your Python program, from this moment on, this name, my variable, has the value 5, and you can refer to it by its name. So for example, as we had before the print statement, I can now say print my variable, and what would it print? Well, it would print the value of my variable, so in this case 5. Let's try it. I'm going to run the program again, and indeed it printed 5. And so you don't need to write the 5 into the print statement, rather you write my variable, and that is useful because you may need to use your variable in many other parts of your code. Maybe you want to do some calculation, so let's create a new variable, result, and you want to use my variable plus 10. And so you can refer to this value 5 by your name that you have given. What actually is happening is, and you are very familiar with this, is that the value 5 will be stored in memory, but the memory position, the memory index where it's stored, is abstracted away from us. We don't need to refer to a particular memory position. You remember in NASM, you can refer to 30, for example, to refer to the 30th memory position. We don't need to do this anymore. We can just refer to it by its name, my variable. It is not important to us where exactly this variable value is stored in memory. That is not of our concern. What we want to know is, how can we get it? How can we refer to it in our algorithm? That's what is important to us. And so this is abstracting away the details of our machine. So this is really the power of high-level programming. We are going to talk about indexing. So we have arrays, for example, if you search for an item or a sort, we will have arrays. How can we index in Python? We are going to talk about slicing. For example, if we think of a string, we have concatenated a string, and slicing a string is the opposite. So we want to maybe have parts of a string. We're going to talk about string arithmetic. We're going to talk also about loops and conditionals. How can you do repeated operations in Python using loops and conditionals? There are different types of loops. We're going to discuss them. And then a big part of our work will also be on documentation. So we want to have our code to be easy to understand. So we're going to talk about how you can comment in Python, how you can document your code. Here are some of the operations to just give you a sense of what is possible in terms of the arithmetic operations. And they're pretty much, what you would expect. So here, if we look at this, The plus is the addition operator. We have the minus for subtraction, multiplication, division, and so on and so forth. So this is nothing unexpected. And then, as we have seen, we have strings. For example, here we have different strings. Whether you used the single quotation or double quotation mark, that won't matter. You can use those however you like. What is important, though, is that you settle on one. So you cannot use a single quotation mark to start a string and then double quotation mark to end a string. That will lead to confusion. Okay, so that's it for today. If you have any questions on installing Python, on your text editors or anything else, come to office hours, send us an email, and we are going to help you to get started with Python. So that is the goal for the next couple of days. Make sure that you have Python on your system installed, that your terminal is working, and that you're ready to go to write Python programs.